Hi guys, welcome back to another session and s- let's see what we are going to learn today. I will just open the curriculum that I have made for myself, even though I'm not sure how good is it. But going through the initial few sessions, this is the fifth one with this new curriculum. I find that it is a bit more instructive and comprehensive than the previous ones. In the first two sessions, although I understood some things, but I was mostly lost. So in the previous session, we learned about Git. We added files to the staging phase, and then we committed. We made changes. We saw introduced some errors. We fixed them. So we understood these commands specifically, and now I think in this session we'll be able to understand what uh, like code can store value in variables and print them, and we should be able to modify a small script and rerun it to verify out. Okay, so before yeah, so first the concepts. Variable concept in plain English. A variable is a named place to store a value. For example, name is equal to Ashish, age is equal to 30. Once stored, the program can use that value later. Print name shows the value inside that variable, not just the variable name itself. So it will output Ashish. Why this matters? Variables are the basis of almost all programming. Later you will use to store input, calculations, list, and objects and variables. For coding, we'll go to. Did we go through this? We went to the first three units in this Learn Python, but let's see if it's there. Yeah, we went through it, so good thing. Yeah, we went through this and we uh, yeah had some brief understanding of the first three. Variable names appear with stored values. Changing a variable changes later output. Short beginner video. Okay, let's see how short or long it is.
It's clear that Python is a great calculator. If you want to do more complex calculations though, you'll want to save values while you're coding along. You can do this by defining a variable with a specific, case-sensitive name. Once you create or declare such a variable, you can later call up its value by typing the variable name. Suppose you measure your height and weight in metric units. You're 1.79 meters tall and weigh 68.7 kilograms. You can assign these values to two variables, named height and weight, with an equal sign. If you now type the name of the variable height, Python looks for this name, retrieves its value, and prints it out. Let's now calculate the body mass index, or BMI, which is calculated as follows, with weight in kilograms and height in meters. You can do this with the actual values, but you can just as well use the variables height and weight, like in here. Every time you type the variable's name, you're asking Python to change it with the actual value of the variable. Weight corresponds to 68.7 and height to 1.79. Finally, this version has Python store the result in a new variable, BMI. BMI now contains the same value as the one you calculated earlier. In Python, variables are used all the time. They help to make your code reproducible. Suppose the code to create the height, weight, and BMI variables are in a script, like this. If you now want to recalculate the BMI for another weight, you can simply change the declaration of the weight variable and rerun the script. The BMI changes accordingly because the value of the variable weight has changed as well. So far, we've only worked with numerical values, such as height and weight. In Python, these numbers all have a specific type. You can check out the type of a value with the type function. To see the type of our BMI value, simply write type and then BMI inside parentheses. You can see that it's a float, which is Python's way of representing a real number, so a number which can have both an integer part and a fractional part. Python also has a type for integers, int, like this example. To do data science, you'll need more than ints and floats though. Python features tons of other data types. The most common ones are strings and booleans. A string is Python's way to represent text. You can use both double and single quotes to build a string, as you can see from these examples. If you print the type of the last variable here, you see that it's str, short for string. The boolean is a type that can either be true or false. You can think of it as yes and no in everyday language. Booleans will be very useful in the future, to perform filtering operations on your data, for example. There's something special about Python data types. Have a look at this line of code that sums two integers, and then this line of code that sums two strings. For the integers, the values were summed, while for the strings were pasted together. The plus operator behaves differently for different data types. This is a general principle. How the code behaves depends on the types you're working with. In the exercises that follow, you will create your first variables and experiment with some of Python's data types. I'll see you in the next video to explain all about lists.
Okay, so not sure how audible was it. Maybe it was coming out of Chrome and Mike blocked it, but basically it was a short video about the types of variables, and we had gone through these in the Learn Python link, which is this variables and types, and basically what understanding we had from that, it just reinforced it. So to look for assignment with equal, string versus number, print variable versus print text. Okay, yeah. Now, okay, so hands-on. Go to week 1 foundation, or we add the RTFS week 1. Let's see. Yeah, we are at our week 1, and then I create a new file, variables underscore demo.py. So I create new file, variables underscore demo.py. So a new file will be created here. This is the new file. You can see it with ls also, variables underscore demo.py. Now add starter code type, project name is equal to root to full stack developer, current day. Okay, so we type project name is equal to root to full stack developer, and let's put a underscore between for visibility. Project name root to full stack developer, current day is equal to 7, and we type print project name, this is the variable, print current day. Type command s, and this dot will disappear when it will be saved. Now I will run this file Python 3 space variables underscore demo dot py. Road to full stack developer 7. That's correct. Okay, now I will make some changes. I will type project. So the separate values separator, should I type project name and have day? I'll save it. Hope this executes. Project and day. Nice. Change current day to another number and rerun. Change the project name, text and rerun. So I think this is done. I've changed the names. Verify with Python tutor. Okay. It says to copy this in Python tutor. Let's see what it shows. So if I type here and I visualize execution, step 1, project name, just executed project name id 1 and string was assigned to it, route to full stack developer. Next is executed. Okay, the integer was assigned to it to current day. Next, it's this executed project and the string after it. Next executed. Okay, done. So we went to this folder, created this file, added a code, ran that code. We added we added some extra text to make it more readable. And if we change it, I think this is the same what we did here in party. We are just going to do the same things. Change the project name and rerun and observe that output follows the variable values. We've done this. You understand that variables store values and print displays them multiple ways. Yeah. So now debug drill, type in variable name, print name, observe name error. Okay. So if I make some errors and I change it to project name, I save it, and then if I run it, I get name error. Name project name is not defined. So if I change it and save it and then run again, get the correct output. So the next error, what has to be missing puts around name is equal to Ashish. Okay. So, but we didn't write Ashish anywhere. Maybe if I just don't put a. I think if I don't put a quote, it's the same thing. If I don't put a quote around project name, I save it and then I try to run it. a syntax error because I should have quotes around it. Okay. Quotes. I save it. Then I run. Runs perfectly. Now create variables, demo pies, store strings. We did this, print them, combine text and values in readable output. We did that, edit values, even yeah. Now yeah, I think this is the same thing, variables. Yeah, we did this. Git for today, git status. So let's see. Okay, we had variables demo py. So let me go to the terminal. We see the git status. I will see that this is a new file and it is not committed, so it will show us that. Variables demo py. This file is not added, so I add variables demo demo.py git status, new file needs to be committed on non-stack. If I add git add git commit -m running program safely day 7, and yeah, we have it. So if we go and see logs, I think this also have to make a habit. If I want to know more, I go into git log, shows all the like it shows in details. If okay, where is the cursor? Where? Okay. It's changed to ZSH from ZSH, but why we're not able to? No previous regular expression. Let me search. So it says press Q and you should be able to return. Okay. So because there are so many commits, it's a big log. So you have to press Q to exit it. So I have to press git log one line. Hmm. Hmm. So moving back, we went through these, went through the YouTube video. Variable demo exists, output verified after editing, and files committed to Git. So this is what we have achieved today. We were able to run, make some changes, debug after introducing some errors, commit those changes, see the status. Also understood that if we type just log and um the output is long, you have to press Q to exit that and go back to the command line instructions in terminal. So now the project includes first variable based script, execution model is becoming concrete, and weekly project foundation is now code plus history and structure. So good going. This session was also not that long, so hopefully we are going in the right direction. And thanks for being here, and see you in the next